Swayam Prabha. Digital India. Educated India.
National Center for Combustion Research and Development at IIT Madras is world's largest combustion research center that aims to promote academic research in combustion and develop trained researchers as well as increase the number of scientists and engineers in combustion research. Let's find out more about it.
I am Satya Chakravarti, Professor of Aerospace Engineering and heading the National Center for Combustion Research and Development at IIT Madras. We call it NCCRD. At NCCRD, we are originally supposed to be an R&D center where we do research on all aspects of combustion, including automobiles, aerospace propulsion, thermal power, fire research, and so on. As we have been engaging with a lot of industry players and developing a lot of research and development for these industry people on combustion, we have also actually been engaging with a lot of startups and have given rise to a lot of startups being housed at the NCCRD, primarily on combustion, but also necessarily not on combustion, but on other aspects of aerospace engineering. The first and foremost that has actually been around here is our Nickel Cosmos that is developing 3D printed rockets to assemble into a launch vehicle to take satellites and put them in space orbits. We are expecting to actually launch our first suborbital flight out of Sriharikota, where we have India's first private launch pad being established for this purpose in the next month or two. I myself am actually involved in E-Plane, the E-Plane company, which is setting out to make electric planes, which is moving away from combustion. Because electric planes have the challenge that they cannot have a very long range, so we can't expect to have airstrips and runways that are very close to each other within the kind of ranges that we can do for electric planes. The world over, people are actually working on something called eVTOLs, electric vertical takeoff and landing planes, which can take off like a drone but fly like a plane, and that's exactly what we are also doing over here. So at the NCCRD, we have housed a team of people at the E-Plane who can do the design and testing of components here, but in the new campus of IIT Madras, we are having facilities to put together full-fledged carbon composite parts manufactured to aero-grade standards and assembling a full plane. And we would test them for hover and so on within the campus, but take it outside for flight testing. So we expect this to actually serve the purpose of air taxis in our Indian cities in about 2 years or so after we put it through commercialization. In the meantime, we are also actually working on several smaller aircraft of the same kind, all the way up to about a 3 to 5 meter kind of wingspans, capable of carrying 50 to 100 kgs of payload as cargo for a lot of logistics applications, and even the smaller one, which is at a level of about 3 to 6 kgs of payload that can do surveillance and last mile deliveries and all those things. From a combustion perspective, we started with actually an innovation on gas turbines, the kind of engines that power aircraft. And that innovation is now being transferred to a startup called Aerostrovilos, which is Greek for gas turbines. And this startup is aiming to make a micro gas turbine of up to about 100 kilowatt power level, which will generate power on demand, on the go, in a distributed manner. It could be used for hybrid microgrids with solar and wind, where you can generate power when there is a deficit in power against the demand from solar or wind, or in the night time, or whatever it is. But we can also actually put it on board trucks that are long haul heavy duty trucks, and as well as long distance air conditioned buses, where electrification of these kinds of vehicles is a huge challenge today. But we can start with an electric powertrain of these vehicles, but put this as a power generator on board on the back end, And the good thing about the innovation that we have done at this combustion center is that this microgas turbine is based on a combustor and a burner that we have developed and patented it across the world, that is extremely fuel agnostic, which means that we can take any fuel that's available on the road, which could be diesel or petrol or natural gas, all the way going to hydrogen. In that sense, this is actually what we call as a transition engine that can usher in the hydrogen economy without having to develop specific engines or fuel cells that would use very high purity hydrogen and so on. In fact, this is extremely pardoning on the quality of hydrogen or quality of any fuel for that matter that we would use, and still generate power commensurate to the calorific value and the purity of the fuel that we use, which means that this can be used in higher altitudes where you don't have much of an oxygen availability. So not only fuel could be compromised, but also the oxygen can also be compromised. So this will actually work very well in higher altitudes for, let's say, RB trucks and so on. Very similarly, we have research done at the NCCRD with our chemical engineering colleague who has actually developed a process that converts unsegregated municipal solid waste that we throw out of our homes into crude oil. This is a process called hydrothermal liquefaction that has been perfected in this center. And it has spawned a startup called X to Fuels and Energy, meaning X for anything to be converted to fuel. And the source of the fuel basically is crude oil. And originally we would think that we want to take this crude oil and blend it with the petroleum crude that gets into refineries. But in the recent past, we have also been toying with this idea that we don't have to necessarily do that at all. And we can take this crude oil and remove the sludge and get a clear oil which has all the components called petrol, diesel, and kerosene and so on. So this oil is called kerogen, and we would like to actually use this kerogen directly into the Aerostovelos engine to spawn a revolution of sorts in the society where we locally generate crude and directly use it into trucks that we are going to be running on the road and locally consume them. So we can spawn lots of jobs and generate the wealth within the country instead of spending it spending it on importing them and going through a huge amount of infrastructure for refining them and piping them or trucking them to a lot of petrol bunks and all those things. So this, I think, will actually become like a circular economy by itself. Very similarly, we also actually have a Earth observation satellite startup that spun out of here. I have been a faculty advisor to the student team on Avishkar Hyperloop, which is meant for developing Hyperloop technology. So I'll talk about that in a minute. But some of the founding members of the Avishkar Hyperloop student team from about 5 years back have now actually started up a satellite company called Galaxy, which is into Earth observation satellites. And for the first time in the world, they are actually putting together a night vision capability sensor called synthetic aperture radar with a hyperspectral camera that works in the visible spectrum that our human eyes can see. And they then actually have a way by which they would do a sensor fusion by looking at the same place at the same time with both the cameras and getting the images to actually fuse so that the nighttime IR, the infrared image that you get, can be rendered as if it has been obtained in broad daylight by means of a deep learning algorithm with artificial intelligence. And that can actually be made available any time of the day, regardless of whether you have a cloud cover or whether you don't have sun's illumination during nighttime and so on. And on top of it, we can actually observe any feature recognition like a movement of a truck or another vehicle or a human being or any of those kinds of things if you want to track any of those kinds of developments. The idea here is that over time, we will actually be in a position to put about a constellation of satellites that gives you a very good revisit time. But in the very near future, as in the next few weeks, we are also actually configuring a smaller version of this payload that can sit on top of one of the E-plane's small drones, which can actually do inspection over very long distances for railway lines, which can look at both the track as well as the overhead power line at the same time and try to find out if there are any abnormalities. And similarly, you can do this for the power grid across the country, or we can actually do oil pipeline inspection and any of those kinds of long distance inspections with this kind of a payload. So going on further, we have the Hyperloop work itself that we have done for the last 5-6 years. We have actually worked with a student team that's been developing the full stack of Hyperloop technologies, including electromagnetic propulsion, electromagnetic braking, which are both contactless, that is required for very high-speed propulsion, as well as also magnetic levitation, so that we can remove both wheel friction as well as air friction. The air friction is removed by actually putting this in a vacuum tube that would run for the entire length of the transportation. And in order to demonstrate this at a subscale, we are actually building a 400 meter, nearly about a half a kilometer long vacuum tube in our new campus to show how we can do a contactless propulsion, contactless braking and levitation of a subscale pod in a vacuum tube, the full Hyperloop stack within the next 2 or 3 months. In which case, we should actually be in a position to scale this up to a larger scale, where we can probably demonstrate this over a 10-kilometer kind of distance, where we can reach peak speeds of about 600 kilometers per hour that can overcome aircraft that are now flying cities, so that we will have what we call as an intercity metro that can be like taking you from one city to another in about 15 minutes to 30 minutes. And that's the kind of future that we are actually working on. And all of these things can be done in the next 5 to 10 years, right, ultimately. So we expect that by the end of this decade, we should actually be carrying our own satellites and our own launch pads and our own launch vehicles. We should actually have air taxis taking you to the nearest Hyperloop station, from which you go to the next city within a short time and go back to your actual destination, the next city, via air taxi again. And similarly, the trucks will be running on fuel that we generate ourselves. We've also actually promoted a hydrogen startup called Nutrace that is making green hydrogen out of water splitting in a way that is very, very inexpensive, by doing membrane-less micro reactors in a modular manner that can bring down the cost of hydrogen production to something that's very affordable within a very short time. In fact, we don't need to wait until the end of this decade for most of these. These are things actually we are expecting to happen in the next 2 to 3 years. So this is like a bigger picture that is emerging out of the Combustion Center, based on the R&D that's being done here, as well as new research that these startups are spawning, primarily largely in the mobility space, all the way to taking goods to space, and not just on the terrestrial ground or in the air. Aerospace engineering is actually at a cusp at the moment, because the world over, aerospace has always been viewed as something that's government sponsored. But today, for example, there's a huge revolution that's being spawned, particularly in India, a lot better than any other countries, on drones, for example, and that's actually an aerospace effort. So, and particularly when you're now looking at going away from multi-copter drones into fixed-wing VTOL hybrids, as they call it, where the drones can take off like a multi-copter but fly like a drone with wings, like a plane with wings. No matter how small, you can actually have long-distance deliveries, long-distance inspections, and all those things, or multiple such trips that can be done without having to swap your batteries, that can save a lot of battery power for doing the same work, because you are making use of the aerospace technology of wings and all those things to minimize the power consumption. That's actually in the realm of the terrestrial. And then we are moving away from that to actually take passengers in what we call as eVTOLs. Further going on, we could actually be thinking about making electric planes that can go from one city to the other. The whole Hyperloop idea is actually sort of aerospace, because we are creating a space-like environment in a tube in which we have to run a pod. So a lot of things that we borrow from space, like how astronauts get into space station across like a vestibule from the rocket to the space station, all of those kinds of things will have to be now done for applying to common passengers over and over again. And similarly, the cabin that we are actually doing for the pod where passengers sit will be similar to a airplane structure. And as a matter of fact, even the tube is actually lightweighted, similar to an airplane, what do you call it, the fuselage, simply because lightweighting will bring down the cost per kg basis and so on. So there is a lot of aerospace technologies that are embedded in Hyperloop as well. Going forward, we can actually think further on doing things like hypersonics, which can take you from, let's say, Chennai to San Francisco in 4 hours and so on. So those are technologies that we are actually developing right here in the combustion center and can be utilized for those purposes as they mature further and further will require more capital, definitely. But as we show that early successes and a lot of things that we're doing, I'm pretty sure younger people will get enthused about diving deep into it, trying to get funding for it, and trying to take a stab at those kinds of technologies. Further on, I think there is a huge amount of potential that's now being unleashed, typically by the government and ISRO, on space technology. And what the ISRO itself is doing with the Chandrayaan mission and the Gaganyaan missions and all those things will actually push the envelope of the kind of space technology that's make accessible to the rest of the entrepreneurs in space tech by ISRO's know-how development. And that can actually spawn a huge revolution in terms of commercializing space technology and putting India in frontier. So if you look at what the government's intent is in the last few years, they want to actually develop very specific technology stacks around, let's say, electric mobility, let's say the digital stack, drones, space tech, these kinds of very key areas. The government is actually pushing very hard on, fostering policies that can enable these to grow really well. 2 out of these 4 or 5 are actually aerospace, right? So if you think about it, the reason is aerospace is what actually brings value to the economy, right? A fewer number of units that are actually put out in the market actually means a lot more work getting done, because we are in the air and in space. We are actually fundamentally designed to be super efficient in the first place, right? And that gives a value for the economy by just putting fewer units, getting more money done, earned for the country. What we are actually, majoring on here is something that we could be classifying as deep tech startups. In fact, these are actually much deeper than most other deep tech startups that we could come across, where we are looking at intense product development that lasts for about 3 to 5 years maybe, right, or even more sometimes. And so we need to have something called patient capital. We have to actually look for somebody who will develop this capital. But more important than that, I think as entrepreneurs, we have to actually start with the business idea. So it's not really about the technology and the product development and all those things. Question basically we have to ask is, what is the problem that we are trying to solve for which customer segment, and how big is this customer segment in terms of a market size that we are trying to tackle, so that we can make a societal impact when we are ready with the technology that's required for this, and what would actually be the price point at which this will fly, and something that could be affordable in the Indian market, for example, and solving Indian problems. So I think entrepreneurs should always be looking for a problem-solving mindset. The problem-solving mindset should actually start with the business case first, and from the business case we should actually be able to figure out at what price point would a technology make sense, and is it possible for us to disrupt that particular technology at the price point that's affordable to potential customers. So if you're able to actually get that product market fit, you are actually ready to go to dive deep into any technology development and corresponding product development.
Hello, I am Muruganandam. I am a professor in aerospace department and also part of National Center for Combustion Research and Development. There is also a center of excellence on gas turbine research inside here, gas turbine combustion research actually. So in all this, the set of ideas are through. One is propulsion of say aircrafts, okay, where we are trying to come up with new hydrogen fueled gas turbine engines. That is, aircrafts in the future will be flying with hydrogen. That we are working on that, okay? And for that we are developing some test rigs which we will be using with hydrogen as a fuel, and then we have to understand how this works with in terms of it will produce different amount of temperature, different flow rates, all these things we have to now work on. We will figure out all these details before the engine companies start implementing in their technology. Yeah? That's one of the research that we work with. In fact, we are partnered with GE right now for doing this kind of work. And getting funding sources from IOE also for this. Okay. Other than this, we have a lot of test rigs related to high-speed flows in here, where our group particularly works on high-speed propulsion, as in something that travels at 6 times the speed of sound, 7 times the speed of sound, that kind of speed. That is, imagine you can travel from Trivandrum to Delhi in half an hour, that kind of speeds. Okay? We are looking at that kind of speed propulsion systems. That is, you have to develop some new engines like scramjet engines, where the flow itself, inside the combustor itself, will be traveling maybe 2 times, 3 times the speed of sound. Okay? In that, we have to now inject fuel and burn it. And the time given is very, very short. So we have to now do specific research, make sure that it will burn within the given time and produce the energy that you need to give that propulsion for the aircraft. That is the main idea of developing a scramjet engine. And we have a unique scramjet engine facility here. We can test different designs of engine flames, etc. inside here. That is actually possible for us. We have other facilities related to high-speed flow test rigs in terms of variable Mach number wind tunnels. We have very unique facility called variable Mach number wind tunnel, in which we have the nozzle itself will be changing during the flow, which will be like the flow the model experiences will be changing in time, which typically doesn't happen in anywhere in the world when they say variable Mach number wind tunnel. During the run, there will be only one Mach number. Okay? Yeah, but we can now run it at different speeds. This now becomes like the flow model is seeing a accelerating flow or a decelerating flow. We can now study accelerating fighter aircraft, decelerating fighter aircraft. This kind of things we can study. What will happen around the body, okay, or what is happening inside a duct, inside that aircraft. All these kind of things can be studied now. Other wind tunnels we have are like models can be moving forward backward, which is again a unique facility that we have in here, where models can go forward backward during the flow itself, in which case I can now study there is a supersonic flow coming, and then I accelerate the model, and then I study how it looks. Okay? That kind of problems can also be studied, which is very unique to our place. Actually, NCCRD alone has these kind of facilities. Actually, it's part of Aero Department also, that particular facility. Like that, we have unique facilities. We have a lot of laser diagnostic systems that are available, with which we can now study several combustion programs. We can also study several individual flame details, okay, whatever is happening inside a combustor. This is where the soot is formed inside a kerosene combustor, or this is how the hydrogen is burning in a hydrogen gas turbine engine, or ammonia burning. We can study ammonia burns this way. This particular flame is the flame that you have. This is where ammonia becomes hydrogen and then it burns. All these kind of details we can now give by tracking individual species inside the flame itself. And this kind of facility, this is the only place in the country where we have such facilities. Okay? In fact, our NCCRD facility is probably the largest in size in terms of all the combustion research facilities around the world as well. Except for a few pressure capabilities, we are slightly low compared to others, but size-wise, we are the best. Some startup companies that are rolling out of here, which are related to the combustors that we actually did research on here, and now they have now become a startup company where they are now producing small gas turbine engines for power generation. That has also happened. There's a company called Aerostrovilos Private Limited, which is actually a company that started off from here with our patented combustor. That is known for working with any kind of fuel. It is actually working with hydrogen as the future fuel as well. And this is one of the rare combustors which works on hydrogen fuel without any problem, fully hydrogen. Typically, all the combustors which they claim in power generation world for hydrogen usage, they use like 40% or 50% of hydrogen max, while we can run pure hydrogen and it still works. So if you think about current day, the push in India is like for hydrogen-based fueled different energy sectors. In that, we are now talking about hydrogen-based IC engines. That's happening in here. Hydrogen-based IC engines to be implemented in a bus, in a tractor, whatever. Different experiments are going on here. There is also a gas turbine engine which we talked about, Aerostrovilos Private Limited. They are going to implement this in a bus and then try to run the bus across the whole of the country after some time. Okay, that is also going on right now. They are in the implementation phase right now. Next, there is also a push for gas turbine engines around the world to go for hydrogen-based fuel completely. In that sense, we are doing the research for that. No, the people are thinking that they will bring in hydrogen-based gas turbine engines around the world by around 2050 in aircrafts, implemented in aircraft. While there are some people who have tried some engines on aircraft already, 1 or 2 people, they are not running it with full confidence that it will always work. They just done it in cruise conditions. Okay, but there's a lot of research to be done. Maybe in 20 years we'll have something working. Most likely 2050 we will have something that came from this lab in an aircraft. Okay. Other than that, we have a high-speed propulsion, which is again one of the more emerging technologies. Currently it's being used in defense sector, but it will be going towards commercial passenger aircraft kind of things, high-speed passenger aircraft. I told, no, Trivandrum to Delhi in half an hour, that kind of flight. Think about from Chennai to San Francisco in 3 hours. That's like remarkable compared to the current 20 hours. Okay? So that kind of changes we can come up with if we can work with this kind of speeds. And that research is currently going on in this particular rig behind us also. That's a scramjet rig where we study this. There are very few people in the country who are doing this kind of rig currently, of which we are one of the bigger players in the academic world. There are 2 other rigs in academia. Other than that, there is only DRDO and VSSC which have these facilities.
As an institute, we have been continuously focusing, at least for the last 2 decades, since I have joined here as a faculty, that all that we do in terms of research must reach the society, must be for the social good, and must translate into something, a tangible product for the society. So this has been the focus of IIT Madras for at least 2 decades now. We nurture startups. As we are proceeding towards our 100th year of independence in 2047, we have 25 years left in front of us, which our Honorable Prime Minister mentions as Amrit Kal. There is a necessity for us to basically come out with solutions that are very important for our society, that are very critical for our society, both for civilian sector and also strategic sector. A country can aspire to become technologically independent, Atmanirbhar, and at the same time can become a technology superpower only if we own the ideas. So intellectual property is extremely important and we need to protect our intellectual property. And we should also nurture our young students, our youth, to start thinking in the direction of trying to innovate. And once they innovate, we need to have a very proper, clear roadmap of how that innovation can be protected and translated into product for social good. We have a very robust patenting mechanism at the institute, wherein when you go with an idea, there is an artificial intelligence enabled tool. Again, an Atmanirbhar indigenous tool developed by a startup company in Chandigarh, XLPAD, through which the student can search, giving the idea as an input to the tool, they can search. And it goes through all the international databases and it gives very, very interesting output in terms of how novel the idea is, what are the other competing ideas, and what is it that they need to do to make it relevant for the market. We have to generate employers rather than employees. And that is the need of the hour, because that is where we create more employment. And if students of IIT Madras, the NIRF 1 institution, doesn't do it, who else will do? This is my motivating talk to all my kids, basically saying, try and become employees and we will help you become employees. My message for innovators is that if you go to several other parts of the world and ask, why are you making a startup? One of the reasons that will come is that, yes, I'm making a startup, I'll attract VC, I'll do some product, and then finally we'll make a lot of, we will settle the equity, probably acquisition, and so a lot of money comes around that. But surprisingly, if you go and ask, what is your startup in IIT Madras? The kids will respond to you saying, I'm trying to solve this problem for social good. right? So our startups in India will be dedicated to solve some good problem for the societies. A need of the society must be addressed. You will witness a startup which has done a septic tank cleaner robo for septic tank cleaners. Today, the Honorable Supreme Court has come out and said there should not be any manual scavenging in the country, which every heart, I think every human being will agree to it. And we have a solution for that. We have done indigenous startup of IIT Madras, J&K operations. I have done an indigenous mobile operating system called BorrowS. Today, that is very important for our security of our country. So there is some societal good that we aspire to. Let us look at a societal benefit that should be the outcome of your startup. That is like the sun. And you go towards the sun. Money, fame, power, all those things will just follow you like a star, like a shadow. Even if you don't want it, will keep following you. But if you leave that and start catching one of that, then you will lose the sun and also the shadow will go away from you. So this is my request and also my advice and to the young innovators.